Watch this window. It slides across the array, and something surprising happens. The algorithm gets faster. There's no recomputation, there's no wasted work, just one idea. And it turns the ON2 problem into ON problem. This pattern is called the sliding window pattern. In this video, we're going to master the sliding window pattern, and at the end of this video, we're going to apply this specific pattern to one of the LeetCode questions. So let's get started. So let's start from the simple main idea of this pattern. So there is a window that's enclosed by a right and a left pointer. The right pointer is going to expand the window as it moves forward, and then the left pointer is going to restore the validity of the condition that's given by the question. And then we track in an ON1 state, and we update our answers when our condition is valid, and both pointers are going to move once. So that's the entire logic of this pattern. So when do we actually use this pattern? The question stem gives us a lot of hints. For example, it could say contiguous subarray or substring. This is one of the strongest hints to use the sliding window pattern. It could also say longest, shortest, or minimum window, or it could be a combination of all of these, longest subarrays, shortest substrings, etc. And the constraint depends on the window state. The window state could be valid or invalid depending on what's inside the current window. And the validity is local to the window. We don't look at the global elements. We just look at what's inside the window currently, and then we compute some sort of condition and then decide whether we move or not. And then the pointers move forward only. This is very important, and because they move forward only, that's why we can turn the ON2 problem into ON problem, because each element enters into the window at most once. Now let's develop a general template code for the sliding window pattern. Let's start from the definition, and we're given the nums array. Let's first initialize the left pointer to the 0th index of the array, and let's initialize a best variable, initialize it to 0, and this is what we're going to report at the end. Then we're going to use the right pointer and its value to loop through the entire array. As we loop through, we're going to add this new element to the window, and we're going to check whether this new window is going to satisfy the condition or not. If it's not valid, we're going to remove the left element from the left pointer from the window, and then we're going to move the left pointer by 1. After this moving, we're going to update this best. Best is initially 0, but after moving this window, we're going to update that best with best, left, and right, these values. And then we're going to move through the entire array using this logic, and at the very end, we're going to return this best. And that's the entire logic of this pattern. And then now let's see if we can apply this pattern to a specific LeetCode problem. Now let's apply the template to this problem, the longest substring without repeating characters. Given a string s, find the length of the longest substring without duplicate characters. For example, S is given ABC, ABC, BB, and then output is 3 because the longest substring is ABC or BCA, etc. So how do we apply the pattern to this problem? Let's take a look at the solution. Let's start from the definition of the function, and we're given this string, and at the end we're going to report the size of the substring using an integer. Let's initialize a variable called scene and initialize it to an empty set, because set can keep track of unique elements. As in our template, let's initialize left to 0th index and then best to 0, and then we will use the right pointer and its element to loop through the entire string. As we loop through, we're going to first check if this character is seen or duplicated inside the window or not. If it's duplicated, like while the ch is in scene, we're going to remove the left element from the window. So scene.remove s left, and we're going to advance the left pointer by 1. So this is checking if there's a duplicate or not. If there's no duplicate, we're going to add this character inside this scene. And after adding this, our window size has changed, so we have to update our window size. Best is equal to max. Using the max function, we're going to compare our initial best, which is 0, and then our current window size, which is right minus left plus 1. We plus 1 because we have to include both sides of the window. And at the very end, after all of this loop is done, we're going to just return the best. And then this is how we solve this problem. Let's check the solution in LeetCode. So it has been accepted and run successfully, and this is how we solve the problem using the sliding window pattern. Hopefully you learned a lot in this video. In our next video, we're going to use this technique and solve more problems, so stay tuned. If you like this content, please subscribe and check out other similar videos.